So, the question of today is, what is the glass transition temperature / point, and why and when does it matter in 3D printing? To give you the most basic answers that most people will give you, the glass transition point is when the plastic simply starts to melt. This doesn't mean that it's in a great flowing state like when you're actually printing with the plastic. This is simply referring to when the plastic just starts to get softer. This can make the plastic more workable and a little more tacky or sticky. So the first reason that this variable is important is because you usually want to set your bed temperature to or around the glass transition point of your material. This allows it to be just a little melted while still having a mostly solid material composition for constructing your 3D prints. However, the reason most people want to know what the glass transition temperature of their material is because of asking, where can I put my print, what can I do with it, and how long will it last? This is where the subject gets a little complicated, because there are many variables that can change the result or answers of these questions. The main reason I proposed these questions as the main ones is because of uses outside, in a car, or everyday use in various conditions. If we use the most common 3D printing plastic PLA as our example, what most people will say is that if you plan to leave your print outside or in the car, just don't bother, because it will melt. However, this is not the final answer in reality. The first thing that we need to understand is the difference between air and surface temperatures. When you have an average thermometer or you look at the weather channel, they are usually measuring or estimating the air temperatures, at least as far as I know, but that would be the logical idea. Now, if you have a thermometer gun, that is usually a highly directional measurement tool that will typically give you a better measurement of the surface temperature it's being aimed at. Different surfaces have different characteristics of how they conduct and hold temperatures. Let's take an average paver brick, for instance. When left in the sun, it can usually absorb, hold, and even transfer the heat on touch, which will result in the brick's surface being hotter than the measured air temperatures. Now, on the other hand, if you take that same brick and leave it in the shade, sometimes even on a hot day with the air temperatures being hot, the brick can hold and transfer a cooler temperature than the air temperatures around it. So the surface that the print sits on, and I imagine the surfaces around the print, can sometimes also be a factor depending on what they are. These surface temperatures are often more important than the actual air temperature. However, depending on what your climate is like, direct sunlight can cause accelerated damage as well. I mean, it will in general, but it can be even faster in harsher conditions. I live in Arizona in the United States.
I'm from Arizona.
Here, the sun it can be harsher than other geographical locations. Either way, there is a certain amount of heat that the sun can transfer directly through its rays in the first place. Those numbers could be lower where you live, they could be higher. It's all situational and not really a static variable as far as my knowledge goes. The degradation of the ozone layer is a factor if you really want to get super accurate about it. Additionally, if you have harsh sun rays, they can just simply eat away at things, even if the temperature isn't necessarily dangerous. It's probably a combination, but my point is that there are some heavy-duty things around my house that still fade and degrade because of the crazy stupid sun. This is of course a natural fact of life, but for many things here, they do degrade faster in these harsh conditions. Now, with all that said, there are factors to combat these hindrances. One of the main things is brighter and lighter colors in general. Darker colors have been said to attract sunlight. Whether or not this is an absolute fact, it's said for a reason. A black print is typically more likely to melt than a white one in the sun. However, the construction settings of your print can also combat degradation. More layer walls and higher infill are just a general good way to preserve the durability of a print. More walls usually means more layers that have to be melted through before a true failure or deformation, and the higher infill just gives the print more structure to fall onto and keep its shape if the outer layers are melting or deforming. But once the infill melts, it's typically game over for the print. Now, with that being said, another huge factor is how the print is going to be used. Now, if the print is purely decorative, it could last longer in harsher conditions, or even almost infinitely if in frequent shade and out of other weather like rain, hail, or snow. However, if the print is meant to be useful or do something, that can make the situation a whole lot more tricky. at least in the long run. Your print is meant to hold a decent amount of weight. Basically anything that actually stays outside is too heavy, then the weight will often crush or deform your 3D printed model to the point of failure. Some honorable mention stuff that I don't personally know too much about is specialized plastics and coatings. Paint and other coatings are used to prevent the rusting, scratching, and other forms of degradation on a car. And I imagine that there is something out there that could at least somewhat do the same for 3D prints, but like I said, I don't know much about that. Now, the subject of specialized plastics is a little different. I know a little bit about it. There is a decent amount of companies trying to make PLA pluses, or, hybrid materials. These typically are advertised for more strength, though they often fall short. However, some companies make chemical alterations to their plastics, or even hybrid them with other plastics to try and give improved results or try to get the best of both worlds when it comes to the hybrid plastics. In the case of PLA, there are some PLAs that have been altered to combat a specific downfall, like UV resistance. UV rays are the main cause of degradation other than heat in outdoor applications, so this can be a good selling point. However, I don't know much of anything about any of the plastics that claim to be UV resistant, how they work, or how many there actually are. Either way, I know that they have existed, or at least that the claims have, and I wanted to mention them as a possibility. So that's all I have to say for now about the subject of the glass transition temperature. If you found this video informative, please consider leaving a like. If I made a mistake, let me know in the comments, but don't be a prick about it. And don't correct me on semantics unless it's actually an important distinction. I tried to cover myself as much as possible, trying not to say anything as fact when I didn't know it as fact. Also, let me know if there is a concept you really want me to talk about and trying to explain in a video, and be on the lookout in the title, description, and probably a pinned comment if I need to make an update video on this concept. Anyway, this channel is a 3D printing and music channel. This video was spawned from a video about how 3D printing can help playing a guitar, but that video went on longer because of explaining subjects like these. Otherwise, I normally review guitar, drum, and sometimes bass guitar gear, and talk about subjects around those. And then I occasionally review 3D printers, talk about issues with them, try to fix them, and otherwise talk about the issues to bring them to attention to hopefully have them fixed from the company, or more than likely by the community. So if any or all of that sounds good, please consider subscribing. That's all I have to say for now, so I'm going to say bye-bye.